Section 5.1 is on bisectors of triangles. The first bisector we're going to take a look at is called a perpendicular bisector. It is a line that bisects a segment, that is, it goes through its midpoint and cuts the segment into two congruent parts, and this line is perpendicular to the segment. So in the diagram here, line CD is a perpendicular bisector of segment AB. Because CD is perpendicular to AB, denoted by this little box right here in the center, and segment AC is congruent to segment CB, so C is the midpoint of AB. One thing I like about a perpendicular bisector is its name pretty much describes what it's doing. It's perpendicular to a segment and it bisects a segment. The perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So for example, CD is the perpendicular bisector of segment AB, and D is a point on the perpendicular bisector, then point D is equidistant from A and B. In other words, segment AD is congruent to segment BD. The converse of this is also true. If a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector of the segment. So given the same picture, if AD is congruent to BD, then line CD is a perpendicular bisector of segment AB. So let's take a look at this example. We need to find the length of BC. So from this diagram, line CD is a perpendicular bisector of AB. We know that because of this little right angle symbol right here and these two little pink hash marks that show that AD is congruent to DB. So since CD is a perpendicular bisector, segment AC is going to be equal to the length of segment BC. So 7x plus 1 equals 10x minus 5, or 3x equals 6, or x equals 2. Now we need to find the length of BC, so we're going to plug that back in. 10 times 2 minus 5, or the length of BC is 15 units. Since all triangles have three sides, they also have three perpendicular bisectors. The point where they intersect is called the circumcenter. So looking at this diagram right here, the purple lines are the three perpendicular bisectors. So each of those lines is perpendicular to a side and it bisects the side. And you can see that that's denoted by all the little pink marks on here. So the point where those three perpendicular bisectors intersect is point P right here, and that's called the circumcenter. So the circumcenter theorem says that the circumcenter is equidistant from the vertices of the triangle. So in other words, point P is the same distance from B as it is from A as it is from C. All of those green dashed lines are the same length. An angle bisector, we've actually talked about these before. An angle bisector is a line, a segment, or a ray that divides an angle into two congruent angles. So if ray BD bisects big angle ABC, then angle ABD is congruent to angle DBC, denoted by the little pink arcs in the angles right there. The angle bisector theorem says that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Okay, so in this diagram, ray BD is an angle bisector of angle ABC, and I know that because of these pink arcs down here. Then any point on the angle bisector, which would be point D, it's equidistant from the sides of the angle. So in other words, remember that distance is perpendicular. Segment DC is the same length as segment DA. And notice that it's denoted by the fact that that represents the distance is denoted by these little right angle symbols in the corner here. The converse of this is also true. If a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. So in other words, if segment DA is the same length as segment DC, then ray BD would be a bisector of angle ABC. Let's take a look at an example here. So we have angle BAD and ray AC. Notice we're not told anything about the measures of these angles here, but we do know that segment CD is perpendicular to AD and segment CB is perpendicular to AB. So if the measure of angle BAC, the smaller one on top, is 38 degrees, and BC is 5 units, and DC is 5 units, then find the measure of angle CAD. Well, if BC is the same length as CD, then the measure of angle CAD is also going to be 38 degrees. If the measure of angle BAC is 40, and the measure of angle DAC is 40, so in other words, these two angles are congruent to each other, and the length of segment DC is 10, well, then we know that the length of segment BC is going to be congruent to that. That's also going to be 10 units. And example number 3 here, if AC bisects angle DAB, the big angle, and BC equals 4x plus 8 and DC equals 9x minus 7, find the length of BC. Well, if AC is an angle bisector, then BC has to equal DC. So 4x plus 8 equals 9x minus 7, or 5x equals 15, or x equals 3. And plugging that back in for BC, 4 times 3 plus 8 is going to give me 20. So the length of segment BC is 20 units. Since a triangle has 3 angles, it also has 3 angle bisectors. And the point where they intersect each other is called the incenter. So all of the purple lines are the 3 angle bisectors, and they intersect at point P right here. So point P is the incenter. The incenter theorem says that the incenter of a triangle is equidistant from the sides of the triangle. So point P is equidistant from side BC, and that distance is represented by the segment PF. Same thing, PE and PD, those all represent the distance from the incenter to the sides. And notice again, distance is perpendicular. So that means that all of the green dashed segments are congruent to each other.